Hi everyone, I am Dr. G. Srinivasu, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In the present video, I would like to discuss the solutions of the first order linear partial differential equations and Lagrange's linear equation. Solutions of first order linear equations in partial differential equations, and especially it is a Lagrange's linear equation. What is the form of the equation, how to find the solution, and we do some examples based on the Lagrange's linear form. So what is the Lagrange's linear equation? What is the general form of the Lagrange's equation? The linear partial differential equation of first order is of the form capital P into small p plus capital Q into small q is equal to R is called as Lagrange's linear equation. The form capital P small p plus capital Q small q is equal to R, where capital P, capital Q, capital R are functions of xyz, where PQ are functions of xyz and small p is equal to dou z by dou x and small q is dou z by dou y. The equation consisting of the equations pp plus qq is equal to r is called Lagrange's linear equation, where p, q, r are functions of x comma small x, y, z. The general solution of this equation will get in the form f of capital F of u comma v is equal to 0. If the equation is in the form pp plus qq is equal to r, where pq are functions of x, y, z, then the general solution will be in the form capital F of u comma v is equal to 0, where f is an arbitrary function of u of xyz is equal to c1 and v of xyz is equal to c2. Here u is equal to c1 and v is equal to c2 are the independent solutions of the auxiliary equations dx by capital P is equal to dy by capital Q is equal to dz by r, where u comma v, where u is function of xyz is equal to constant and v of xyz is equal to c2 are the independent solutions of this equation. Now how to solve this equation? There are two methods to solve this equations. First one is method of grouping and second one is method of multipliers. So what is method of grouping? Suppose if the given subsidiary equations are dx by p is equal to dy by q is equal to dz by r. In this case, you take, if possible, any two of the equations, that is first and second, or second and third, or first and last. That is dx by p is equal to dy by q, that is one side, or dy by q is equal to dz by r, or dx by p is equal to dz by r. You take any set of two equations and directly solve the equations to get the values of u of xyz is equal to constant and or v of yz is equal to constant or w of zx is equal to constant, because first two equations are related to xy only, second two equations are yz only, or first and last, that is combining, you will get dx by p is equal to dz by r, that is a function of z and x is equal to constant. This gives the complete solution. So once again I will tell you, if the equation is in the form pp plus qq is equal to r, then this equation is called Lagrange's linear equation and the solution will be in the form f of u comma v is equal to 0, where u of xyz is equal to c1 or v of xyz is equal to c2 are the constants, c1, c2 are constants, and these solutions are the solutions of the subsidiary equation dx by p is equal to dy by q is equal to dz by r. And these equations can be solved in two methods. One is method of grouping, other one is method of multipliers. In method of grouping, you take any two equations, first, second, or second, third, or first, third, and you solve the equations to find the functions u of xy or v of yz or w of zx is equal to constant. This will give the solution of equation number 1. In other method of multipliers, This is based on the following elementary result. If A1 by B1 is equal to A2 by B2 is equal to so on, AN by BN, then each ratio is equal to L1 A1 plus L2 A2 plus so on plus Ln AN by L1 B1 plus L2 B2 plus so on plus Ln Bn. Each ratio is equal to, this is equal. Now consider dx by p is equal to dy by q is equal to dz by r. If possible, identify the multiplier Lmn, not necessarily a constant, so that each ratio is equal to Ldx plus Ndy plus Ndz by Lp plus Mq plus Nr, where Lp plus Mq plus Nr is equal to 0. You have to find the values L, M and N such that this equation will satisfy. Then Ldx plus Ndy plus Ndz is equal to 0. On integrating, you will get the solution Uxyz is equal to constant. Similarly, or otherwise, we get another solution V of xyz is equal to k. The solution is U of xyz is equal to c. Similarly, we get another solution V of xyz is equal to k, independent of each the earlier one. We now have the complete solution constituted by U is equal to c or V is equal to k. Then the solution will be capital F of U obtained in the first case, V obtained in the second case is equal to C is the required solution of the given equation. So you can do either using my method of multipliers or method of grouping. So that is based on the possibility of the given equation. So this way can be done by using one example. Consider the problem number 1. Find the general solution of x square p plus y square q is equal to x plus y into z. Clearly, what is the notation? Capital P into small p, capital Q into small q is equal to R notation, where p is x square, q is y square, and z is R is x plus y into z. Here small p is dou z by dou x, small q is dou z by dou y. Clearly, it is in the form of Lagrange's linear equation of the form pp plus qq is equal to R. Now write the auxiliary equation. To find the solution, you need to write the auxiliary equations. The equations are dx by p. P means x square. Here p is x square. Right, where q is equal to y square. And what is R? X plus y into z. Q dz by. So see this equation. This is equation. pp plus qq is equal to R. So the equation is, on writing this is pp dx by x square plus dy by is equal to dy by y square is equal to dz by x plus y into z, because it is z also there here. Now, on equating the first two equations, on considering the first two set, dx by x square is equal to dy by y square. Dx by x square is equal to dy by y square. On taking integration both sides, dx by x square is equal to integral dy by y square. So what it is? Integral x power minus 2 dx, x power minus 2 plus 1 by minus 2 plus 1, or it is minus 1 by x. The first integration, minus 1 by x is equal to minus 1 by y is plus c1 constant. Am I right? Or I can write this is the solution is x inverse minus y inverse. Right? This on multiplying with the negative sign, x inverse is equal to y inverse plus c1, or x inverse minus y inverse power minus 1 is equal to c1. This is the solution of u of xyz. U is equal to x power minus 1 minus y power minus 1. On taking cancellation, you will get minus c1 again. It is some constant, either c1 or c2. Then the solution will be x power minus 1 minus y power minus 1 is equal to c1. Here on integrating, you can write like this. Similarly, on considering the grouping dx by, here you can see that we know that dx by x square is equal to dy by y square is equal to dz by x plus y into z. Am I right? Or by I can write each ratio is equal to some formula, because based on that you can write dx minus dy by x square minus y square is equal to dz by x plus y into z. Am I right? So this I can write d of x minus y by this a minus b into a plus b notation. I can write a square minus b square. That is dz by x plus y into z. Or x plus y both cancel. This is x minus y, there is no change. X plus y gets cancelled. So this is x minus y as it is, no change. So dx minus y by x minus y is equal to dz by z. So on taking integration both sides, integral dx by x, that is log x minus y is equal to, this is log z plus log some constant c. Or what we can write, x minus y is equal to or minus z. Or I can write here log x minus y minus log z is equal to log c2. Or log x minus y by z is equal to log c2. Or x minus y is equal to, or x minus y by z is equal to c2. Or x minus y into z inverse, z power minus 1 is equal to c2. That is the solution of this subsidiary equations by considering dx minus dy by x square minus y square is equal to dz by x plus y into z. So that is v is equal to, what is v? This is v. V means x minus y into z power minus 1 is equal to c2. This is the second solution. Now, the complete solution, the general solution is f of u comma v is equal to 0. That is function of, this is 1 by x minus 1 by y, first one. Second one, x minus y by z is the second one, is equal to 0, is the required solution of the given partial differential equation in the Lagrange's form. So I hope this is clear, very easy. So dx by p is equal to dy by q is equal to dz by r is the subsidiary equation. To solve this, we can go for method of grouping or method of multipliers. We can choose any one of those methods and find the solutions. Then f of u comma v is equal to 0 is the required solution of the given Lagrange's linear equation. Now I will go with one example, another example, the similar form. This is solve the differential equation, partial equation, where there is a p means, q means it is a partial derivative, p means dou z by dou x, q means what? Dou z by dou y. These two are the partial derivatives. And x square y minus z into p, y square z minus x into q is equal to z square into x minus y. This is the given equation, and this is in the form capital P into small p plus capital Q into small q is equal to R. So what I can say that it is a Lagrange's linear equation. What is P here? What is capital P here? The capital P is x square into y minus z. And what is capital Q? Y square into z minus x. And what is R? Z square into x minus y. These are the P, Q, R values, where P comma Q comma R are the functions of x comma y comma z. So the auxiliary equations are dx by capital P is equal to dy by q is equal to dz by r. That is dx by p is x square into y minus z is equal to dy by y square into z minus x. I am writing this. Then dz by z square into x minus y. So all the three values p, q, r form. Now you can have the formula. You can write here dx by, what I can write, x square into y minus z is equal to dy by y square into z minus x is equal to dz by z square into x minus y. So this is the subsidiary equation. So from this I can write dx by x square by y minus z, dy by y square of z minus x is equal to dz by z square of x minus y. So you have to choose such that these values on adding you will get zeros. Y minus z plus z minus x plus x minus y is equal to 0. Similarly, so these values on adding y minus z plus z minus x plus x minus y is equal to 0. That means what? The numerator part addition also 0. That is dx by x square plus dy by y square plus dz by z square is equal to 0. So on integrating on integrating both sides, what we will get? Integral dx by x square plus integral dy by y square plus integral dz by z square is equal to some constant, suppose a. Then what is dx by dx square? Minus 1 by x and minus 1 by y minus 1 by z is equal to constant. Or on multiplying with negative sign, 1 by x plus 1 by y plus 1 by z is equal to some constant a. A or a1 or whatever you can. This is the function u. The u of xyz value is 1 by x plus 1 by y plus 1 by z is equal to a. I hope this is clear. Dx by this one, I can rewrite this as dx by x square by y minus z, dy by y square by z minus x, dz by z square by x minus y. So as the summation of these three values 0 and this value's summation is equal to 0. So that is equal to, on integrating, you will get the first solution. In f of u comma v is equal to 0, you already obtained that is 1 by x plus 1 by y plus 1 by z is equal to a. Now on considering the second one. So how I can dx by x square into y minus z? So I am writing the old equation dy by y square into z minus x plus a dz by z square into x minus y. This is the equation. I can write x in the numerator side, that is 1 by x into dx by x into y minus z is equal to 1 by y into 1 by y dy by y into z minus x is equal to 1 by z into dz by z into x minus y. Already one z is went to the numerator part. Then clearly xy minus yz plus yz minus zxy plus zx minus zy. Clearly these values are, on adding you will get 0 denominator terms. So that what you will get 1 by x dx plus 1 by y dy plus 1 by z dz is equal to 0. Now on integrating both sides, what you will get? Integral dx by x plus integral dy by y plus integral dz by z is equal to c or some constant b. So what you will get? Log or log b. So log x plus log y plus log z is equal to some log b, or log xyz is equal to log b, or xyz is equal to b. That is the function v of xyz, because v of xyz is equal to some constant that you have obtained as a second equation. Therefore, the solution is the function of u comma v is equal to 0. That is capital F of what is u? U is equal to 1 by x plus 1 by y. And what is the second? So 1 by x plus 1 by y plus 1 by z. I will verify it. The solution is 1 by x plus 1 by y plus 1 by z is equal to a. And what is the second equation? The second equation is xyz is equal to 0, which is the required solution of the given differential equation. So if the given equation is in the form p small p plus q small q is equal to r, this is called linear equation, and it is called Lagrange's linear equation. The solution is the substitute solutions of dx by x is equal to dy by y is equal to dz by z. So on solving by using method of grouping and method of, what is other method? Method of multipliers. So by using these two, we can find the solutions that u of xyz is equal to c1 and v of xyz is equal to c2. Then the combination of these two is the general solution of the given equation, that is f of u comma v is equal to 0, or f of u of xyz, that is u of xyz comma v of xyz is equal to 0. This is the required solution of the given partial differential equation. So with these few terms, the two problems and the methodology, I conclude my video. And the reference book is Dr. TKV Iyengar, Dr. B. Krishnagandhi, S. Ranganathan, NV, SS and Prasad. A textbook of engineering mathematics, volume 2, page numbers 170 to 176 by S. Chand and Company Limited. So it is published in the year 2001. So if you want, you can verify this book, Mathematics, Engineering Mathematics, volume 2. So thank you for listening. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.